Graph -5 less than or equal to x minus 4 less than or equal to 2. First of all, I want to solve that before I worry about the domain. So in order to solve, this is a conjunction. First off, notice these are less than symbols. That's on purpose. They're supposed to be less than symbols. Smaller number less than some x expression, smaller than some bigger number. And what my goal is to get x in the middle. That's what solve looks like in a conjunction. I'm going to keep the less than symbols as they are. So that's less than or equal to. This is also less than or equal to. Make sure you pay attention to equals to on those. And in order to make x minus 4 become x, I have to add 4. And the rule states if I'm going to change one piece, I have to change all pieces the same way. So I have to add 4 there, and I have to add 4 there. There's 3 pieces to this. All 3 pieces must be modified the same way. I simply evaluate each individual piece. -5 plus 4 makes -1. 2 plus 4 makes +6. That creates a good graphable conjunction. X in the middle, that's what we're looking for. If I'm reading it from x to the number, this says x is greater than or equal to -1. Even though it's a less than symbol, if I'm reading from x to the number, x is greater than or equal to -1. This says x is less than or equal to +6. So I'm looking for numbers greater than -1 going this way, and less than +6 going that way, and I got to stay within those boundaries. So when I put my numbers on my number line, I want to make sure -1 and 6 show up. And I'm going to put a closed circle at -1 because -1 is included and -1 is an integer. I'm going to put a closed circle at 6 because 6 is included and 6 is also an integer. And then I simply need to graph all the integers bigger than -1 that are also less than 6 at the same time. So I'm going to go this way until I hit the end, and then I stop. And again, I'm only graphing integers, so I'm going to graph 0, which is an integer. I'm going to graph 1, and 2, and 3, and 4, and 5. When you're graphing integers, it's 100% of the time they're filled in circles. Never ever do you put a hollow circle. This right here, when you graph it, when the set is integers, this right here does not happen, ever. Only closed circles occur. There's the first integer that starts it, there's the last integer that ends it. If it continues on forever, integer, 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 dot, 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 until you get the arrow, then make the arrow bold. All right? But integers never ever have open hollow circles. Just make sure that you consider that when you're graphing.